Okay, the first question, u is 2I minus 7j, t is 4, and v is 14I plus j. And we are looking for the acceleration. So I'm going to use v equals u plus at. Now, your v is 14I plus j. Your u is 2I minus 7j. A is what we're trying to find, and you know t is 4. So bring the i's over. So 14I minus 2I is 12I. Bring your j's. So 1j plus 7j is 8j, and that equals 4a. Divide everything by 4 to get a. So a is 3I plus 2j, and put the units in, meters per second squared. Now, part 2 is find the distance p to q. So we can use any of your formula if you stay away from the v squared one. So I'll use s equals ut plus a half a t squared. I'm underlining the vectors. So s is what I'm looking for. U, t is 4, a half of a, and a you've worked out is 3I plus 2j, and t is 4, so t squared is 16. So 4 times 2 is 8I minus 28j. A half of 16 is 8. So 8 outside the brackets, 8 times 3 is 24I plus 16j. And just tidying that up, 8 add 24 is 32I, and minus 28 add 16 is minus 12j, and that's in meters. We also have to do from that question, or that paper, question 3. So it's question 3. So it shows you the wee graph. I'll just quickly sketch out the wee graph here. So this first one is 3 up to 10. It's a velocity time graph. And then it holds that. Now t, and then it's got down to here, and then it just stops. And that wee bottom distance is 6 2/3. So describe the motion from t is 0 to t is 3. So that's your first question. So it's accelerating, and it's constant acceleration. The next one, part 2. The athlete starts to accelerate at times t. Find the value for t. Okay. Now, we're told it's a 100-metre race, so I haven't that bit of information in. So that means the area under all this is 100 metres. So the area of this triangle, I'll draw it out to make it clear, so it's 3, 10. So the area of that triangle is base times height divided by 2. So it's the distance, it's the area. Now, this middle rectangle, just be very, very careful with that. Time t is from here up to there. So the width of your triangle, or sorry, your rectangle, is actually t minus 3. So that's t minus 3, and it goes up to a height of 10. So the area of that is 10 times t minus 3. So it's 10t minus 30. The last shape, just be super careful over here. The last shape that you've got here, you've got a triangle and a rectangle underneath it. So basically, it's your trapezium. This height is 10. This height here is 6 2/3. And looking back at the question, because I need more clues here. It says in the question the total time is 11.8 seconds. So the whole race was 11.8 seconds. So this wee bit in here is going to be 11.8 seconds. Take away the t. So 11.8 take away t. So how do you find the area of trapezium? You add the opposite sides, you divide by 2, and you times it by the distance between them. So tidying this all up, I'm sorry, you know that this here is 100, so we should put that to be 100. So 100 equals, that's going to be 15 plus 10t minus 30. Now working out that wee bracket in there, so it's 16 2/3 for the top line. So 16, I should use a wee fraction, but 16 2/3 divided by 2, 25 over 3. So it's 25 over 3, 11.8 minus t. So my next line is 100 equals 15 minus 30 is minus 15 plus 10t. Expanding out that wee bracket, so 25 over 3 times 11.8 gives me an answer of 295 over 3. Take away 25t over 3. So move the calculator so you can see it. I want the t's on one side and the not t's on the other side. So I'll just move this over and it becomes an add. Move this over, it becomes a take away. Equals, and I'm left with 10t minus 25 over 3t. So tidying up this side is 115 minus that answer to give me 50 over 3. 10 take away 25 over 3 gives me 5/3 t. So the bottom's knock off. So t has to be 10. And that's what the question is looking for.